introduce this smart device. This is smart digital home protector. What is inside I will show you. I'll introduce this device first. This device has 3 connectors. See, one is input, another is output. I have marked this red. This is power output and this is the input. And I'm using this one is where this is for neutral, and this will be the input of phase, and this will be the output. Let's see what is inside. To explain this device, I'll open and then I'll describe one by one, and I'll show you the outer portion first. This is the main unit. This device can display the load, frequency, voltage and total consumption, and you will get cumulative figure. Say for example, today your consumption is 1 kilowatt and it is ongoing, and next day you consume 2 kilowatts, so it will show you 2 plus 1 3 kilowatt, as it will show cumulative figure. And see, here is another display device. This is for input voltage. What will be the input voltage you can see here, and this device will show the output voltage. So this is for input and this is for output, and you can see 5 LEDs are there. First one this is for power. Once this device will get power from this input, then it will be on. That means the device is on. Next we'll get pulse display. That means if this device is working properly, then only you will get this pulse. First time when you connect this device, then the pulse light will be off. Once the device is ready, then it will start. That means you can see this pulse display here. It will blink. Next one is yellow color. This is red, this is green, this is yellow. This yellow color will not glow first time. After the device is on, then pulse will start, and after a certain time, I have already mentioned that in this device one feature is there which is called on time delay. In this device, or I have adjusted to 1 minute 10 seconds. So you can adjust any time as you wish, but here it is selected around 1 minute. That means 60 seconds. So after this 60 seconds, once the 60 seconds is over, then only this light will glow and it will give the output. I repeat, when the device is on, this red light is on. After few seconds, this pulse will start. Once the pulse started, after it will count 60 seconds, then this yellow light will be on. Yellow light will be on. That means if this light is on, means this device will get power, and from this device the output will get from this. I told you one is input and another is output. So you are getting output from that wire. And next is this one. What will show? This one will display you the high voltage. If the device is getting high voltage, that means if the input is around 230 or more, that means you are getting high voltage. So output device will be automatically off, and this light will be on, and it will display the high voltage. And this light will be it is different. What is for? This is basically used for the alert purpose. That means I'm using one switch here. So this is for bypass. If the device is not working, but you need the output, then what will you do? You need to repair, then only you will get it. So to bypass this system, or for emergency purpose, we are using this switch. This is for bypass. That means if the bypass system is on, that means this device is not working automatically. So all the function of these LEDs, these two devices, this one also, and I'll show you what is inside. I'm using different parts here. At first I will show you this device. This is basically for display, not to operate any voltage, not to do anything. This is only for the display purpose. This one also, it will display the input voltage. Now check what is inside. See, this is the main part of this device. You can see I'm using 3 ICs here, integrated circuit. First one, this is 555. You can see this 555 IC. This is for pulse generator. Just nearby this is 4017. You can check this number, 4017. This will control the output voltage. This is basically for on-time delay. This pulse generator will generate pulse and it will continuously feed the pulse. After a certain time, this controller IC will pass the voltage through this pin, and from this pin it will go to the main board, and after that there is a, I'll show you here. I'm using one optocoupler. Just let me take it out. This tiny board can do many things. This is contain a optocoupler. You can check it. This optocoupler will work as a relay. That means when this controller IC will give pulse to this pin, that is after a certain time, through this preset you can set the pulse. After 60 seconds this will pass the voltage to this pin, then it will go to this optocoupler. This optocoupler will switch on the output. You can see here many pins they are connected through the main board, and this IC, this is for provision. I thought that I'll add few more features, that's why it is fixed here, to display input and output simultaneously after a certain time or certain interval. These features will be added later. So basically we are using these 2 IC for this project now. That's why I'll explain. These will generate the pulse, and after that these will count 60 seconds, and after that it will pass the voltage. Then this optocoupler will work as a relay, and then this device will get the output. So this is the main function. Now I'll show you the main board. I'll take out another device. You can check this. This is also another important part. This is main load controller. Actually those are triac. I'm using those triac to control the output voltage, and through this triac I can adjust the voltage also, output voltage. You can see this preset control the output. That means as per your choice you can set the preset so that you can get the desired output. So this triac will control the output, and when I'm getting the trigger from this optocoupler will work as a relay. I already told you this optocoupler will pass the trigger to this triac. then this triac will start working, and then this will pass the voltage. So this each triac can hold up to 40 ampere. So 3 triac I'm using in parallel, so it can hold 120 ampere at a time. You can increase this as per your requirement. This is for input output voltage display. All are connected to this board. There is another major part in this circuit. I'll explain. You can see this. This is another module. It is also separated and I have fixed here. This module will control the high voltage cutoff. First, when I am getting AC voltage through this module to this control this circuit, this module will check the input voltage. If it is more than 235 or even as per your choice, you can set anything. So through this preset, you can set the cutoff voltage. After that, once it is getting high voltage, then it will cut off and it will stop the output voltage. That means this trigger will also off. That means output voltage is off at that situation. Then once the voltage is stable, then it will pass the voltage and it will start the circuit. Then again it will start the counter and start all the function one by one. So this device basically controlling the cutoff, that means high voltage. This function is working through this module only. All are handmade. I'm not using any ready-made module. All are handmade. You can see the PCB, you will understand very well. So this is motherboard, you can say. All the module and spare parts are connected to this board. Even all jacks also. This board will supply to everywhere. See, all are connected. I'll show you these two triac. This triac is used for a different purpose. I'll explain it later. So these slot I'm using here for optocoupler, and this portion is separated. It is for main trigger and there is two for different purpose. It is not added here. That's why I'm not going to explain right now. So here I'll sum up this device. At first I'll get AC voltage. I'm taking input from this. See this red mark, this is the output, and I'm getting AC input here. I'm getting neutral input here. So these two input will enable this circuit. And after once the trigger is on, then only I'll get in output to that connection. So that will be the output. So once I'm getting 220 in this transformer, this is 300 milliampere transformer. This will supply the AC power to this module. This module will check the input voltage. If it is higher or not acceptable, then it will automatically cut off this circuit. Different LED, it is already mentioned. This light will be on, and you will come to know that why the device is not getting the output. That means the input voltage is high, and this voltmeter will show you the actual voltage. Once the voltage is stable, or say for example, once this device is on, the voltage was stable. That's why this module will pass the supply to this main board. This main board will supply the power to this controller. This is the main controller. This controller will get power. You can see the pulse display in front through the LED, and after certain time, I fixed here 60 seconds. So after certain time, you will get output through this pin. This pin will trigger the optocoupler. Already told you, this is the optocoupler module. All are handmade. You check this. This module will pass the voltage to the triac. and these module will work as a relay. So these module will control this track. This track will control this to enable the output, and this optocoupler is very vital. This is very sensitive too, and this module will always monitor this. The function of this optocoupler is very vital. Now this, through this circuit, I am controlling this track driver. This optocoupler will power switch on this. That means it will trigger the track to give the output. And here, through this preset, here you can set the output voltage. Then the desired output will pass through this voltmeter. I'm using another voltmeter here. You can see this, which I showing you first time. This voltmeter will show you the frequency, output voltage, output load, and the consumption, everything along with frequency. Through this module, sometimes we are getting different frequency because it is going through the track. So to ensure, we are using this meter to measure the exact output. So this is the main principle, and after that, through this voltmeter we can understand the what is going on in output section. And this LED panel will show you what is going on inside. This is the input voltage display counter, and there is, I'm using another bypass switch. This bypass switch will work only in case of failure of this circuit. Once this circuit is working properly, this function will not work. That means it is not required for any use. If this circuit is failed for any reason, then only you can use this. So this is all about this circuit. All are handmade, and I'm always trying to make something new using very simple component. So all you can see here, it is available in local market, and this device can save all home appliances. Even it can control the air conditioner, geyser, and as well as the washing machine. That means, I mean to say, any kind of high load application it can handle. And if you think that if you need more load, then you can increase the track, so it will give you more power. So this is all about this circuit, and this the function of this circuit is very accurate. I have already checked and it is already tested. Show you later. So this is my dream project. I'll use this for my own home, and last 7 days I've used this device. It's working properly. I'll recommend all of you, if you try, you can also make it. Keep in mind one thing: you need to gather all the parts one by one from the different source. This is a big job, and after that you assemble and you design this circuit. I'll prepare this circuit and I'll share with you so that you can also make it. These two wire, one is input and another output. Now I'll switch on this and I'll show you how it will work. Power on this device. This is for input. This is neutral, main, and this is for the output. For example, I'm using, to show you the demonstration, I'm using this 100-watt bulb. I'll fix it here. This is 100-watt bulb. Now I'll switch on this device. We're getting 233 volt as the input voltage. And just check this. This light is on. This device is showing only one LED, and the input voltage is 232 volt. That means you are getting the input voltage at 232 volt. I'll show you through the display. Through this meter, I'll show you the voltage. Now only one LED is there. One LED is glowing here. Getting pulse. I told you that these pulse will come later. At first, you see this power is on. I'll measure the input voltage. Yes. I'm using here. See, this voltage is on. That means after a certain time, this counter will be on and this LED is glowing. This is for pulse. This LED is on and it will not glow now. It will show you later. What you can see here, this is power, this is pulse, and this is the output voltage. Once this yellow LED is on, that means you will get the power. And the output voltage is 199 volt. That means 2 volt, it is fixed as 2 volt. And the load is 78 watt. Mind it, load is 78 watt. 77.7 or maximum 78 watt. It is 100 watt bulb. I'll show you it is 100 watt bulb and it's consuming only 78 watt. And the frequency is 49.9 hertz. And this is the load. And this will be the consumption. So I'm getting 199 volt right now. I can change this voltage. I'll show you. Once you are using this device, make it sure that you are using the proper insulation. Here I am getting 199.7. Just check this, 199.7. Now be very careful. It will be radio, it will be increased. Through this preset you can change this. See? Now I want to fix as 210 volt. Let's see. $210 volt. Check. It is 210 volt. I'll switch on this circuit again for this demonstration purpose. Power off. I'll show you the input voltage. Just check this meter. Please ensure that it is selected the right. 232 volt. It's showing 232 volt. The input voltage is 232 volt, but output is 210 only. So there is a difference. You can set 232 volt, 220 volt also. This is 12 volt. So in place of this 100 watt bulb, I'm using this 14 watt LED. Let's try. This light is on. Now we'll check how much actually it will consume. So this LED bulb, it is written on this box, it is 12 watt. Sorry, not 14 watt, 12 watt. So this 12 watt bulb, how much actually it will consume? I am to see this through this voltmeter. Just I'm waiting for the pulse. Once it will pass this, then only it will be on. You need to wait till the time you set. this, the controller will enable the output after a certain time as it is selected as on-time delay features. Now the display showing here 7.3 watt. I repeat, 7.3 watt, but I am using 14 watt LED bulb. A 14 watt LED bulb can consume only 7 watt. That means through this device, if you are using any appliances, so it can reduce the load. I'll repeat. Now the load is 0, and check this. I'll show you this bulb again. It is 12 watt. Now fix this. Be very careful. Now load is 0. Check that. The watt is, it's showing only 7.3 watt. That means it can reduce the load. It is proved. Now I'll show you how it will cut off the high voltage. To show that, we need to switch off again. This time I'll not using, this is direct connection. I'm using this controlled output. I'll switch on this circuit. It's showing 199 volt. This light is on, that means it is under control. Now see,